Hello, my name is James Pinkl. I am a student and researcher at the University of Aizu Spatial Media Group in Fukushima, Japan. Today I will be presenting Spatialized AR Polyrhythmic Metronome using Bose Frames Eyewear, which summarizes some work I have done with my advisor, Michael Cohen. I'll first explain some key concepts to this research, like metronome and polyrhythm. Then I'll go over some background on the Bose frames themselves, and then I'll talk about the motivation as well as implementation and close it out with a demo. A metronome is a widely used tool for musical practice to help keep players in time. It operates by playing back an isochronous tempo so that the player doesn't stray too far off from beat. The output of the metronome is often chosen to be headphones, and because of the diotic playback of the metronome itself, it creates the intracranial audio effect, giving users the illusion that the sound is emanating from inside the head. A polyrhythm is a musical technique that has two different but mathematically related tempos simultaneously. For example, a 5/4 polyrhythm would sound like this. The goal of this research was to develop an application that better helps musicians understand and learn polyrhythms through the use of AR and spatial audio. The resulting effects of this application were then evaluated via test subjects. By putting on the Bose Frames, which is a newly released AR audio product with head tracking and audio expression in the ear stems, and connecting to my device running the application, I am then prompted with this connection screen before being brought into the main application, which has automatic head tracking, as you can see, and an interface for turning on metronomes of different tempos. The application's head tracking will automatically adjust the binaural audio expression, creating the illusion that the two metronome audio sources are in the room. The touchscreen operated joystick also lets users further spatially mix the soundscape. There are also presets for room model reverb, which were implemented via the Google Resonance SDK. A pilot study was done to have 5 subjects compare polyrhythmic metronome tracks rendered in 4 different ways. They were diotic, sometimes referred to as mono, dichotic biphonic, sometimes referred to as stereo, 1/3 stereo, where the two sources are panned at about 33% from the listener, and first order ambisonics, where the two sources were located at, again, about 33% from the listener. The 2 playback methods were headphones and Bose frames. The results are encouraging, as the first order ambisonics file sounded the most realistic on both displays. Furthermore, with the frames, the ambisonic audio file was the easiest to entrain or lock into the groove. For future development, we are considering ideas with MIDI, VR deployment, and groupware capabilities. Thank you for your time and attention.